we're going to have an equation 3 times e to the 5x minus 1 plus 1 equals 151. Quick reminder that that e value it's like a special number. It's kind of like in the same way pi is a special number. We use a symbol to represent it. It's about equal to 2.718, and it is simply a button on your calculator, just like pi is a button on your calculator. And as you do higher levels of math, you'll see that number more and more and more. But when you see it, just be like, oh yeah, it's a number. It's like between 2 and 3, and then don't stress out about it. We're going to try to get this x by itself. That's our concern right now, and nothing really changes. We're still going to use PEMDAS in reverse, and we may have to do the conversion at some point. I mean, considering that our unknown is in the exponent, logs will come into play. As I look at this left side of the equation, my first question is always, is there anything to add or subtract? Of course, I'm not looking up in the exponent because I haven't worked my way up there yet. I'm just looking down here. I can see that they added 1, so I should subtract 1 from both sides, giving me 3e to the 5x minus 1 equals 150. My next question is there anything to multiply or divide? And I will say this 3 in front is a multiplier. The base of this exponent is e, and it's being multiplied by 3. So that 3's gotta go before we switch to any kind of form. Since that 3 is multiplying, of course, we will divide both sides by 3. That gives me e to the 5x minus 1 equals 50. And now that I just have something raised to a power equal to something else, it's time to switch to log form. And the questions are, what's my base? Where's my exponent going to go? And my base is going to be e. So this is like another quick reminder, when your base is e, we actually write ln. It means natural log, or log naturel. It's actually natural log. It's how Americans say it, and probably everyone else. It's just a button on your calculator. It's right here. It's by the log button. So we don't need to actually write the base down. In fact, if you wrote the base down, we would laugh at you inside of our heads just a little bit and say, hee hee, they wrote base e instead of ln. But you're just going to use ln. So I'm going to say log base e, or ln. The exponent goes over here, and the 50 is on the inside. And I'm just going to, I don't need to use any change of base formula here. This is kind of nice. I can just use the actual ln button on the calculator to find out what the natural log of 50 is. So I'll press the ln, I'll put in the 50, I'll press equals, and I'll get some gross decimal, 3.912. 3.912 equals 5x minus 1. And now it's like an equation I might have had a couple years ago in math. I got to get this x by itself. I'm doing PEMDAS in reverse, so I'll start by adding 1 to both sides. So I'll have that 5x is equal to 4.912. And then since this 5 and x, this 5 is multiplying, I'll go ahead and divide both sides by 5. I don't really want to do that mentally or on paper, and I didn't want to push that button either. I wanted this button. 4.912 divided by 5, and my final answer is 0.982. 0.982. And that's it. So again, 90% of this is stuff you guys know how to do. If they add, you subtract. If they multiply, you divide. But if once you have something raised to a power by itself, we switch to the log form. And when that base is e, our jobs are a lot easier because we, instead of using a change of base formula, can just bust out this ln button and life is good. So, good luck.